This is an exceptional case where we have potassium permanganate. That is, to name it using the IUPAC nomenclature, this is potassium tetraoxomanganate 7, reacting with hydrochloric acid to give you 2 salts. This is just a laboratory preparation of chlorine. You can otherwise call it potassium HCl method. All right, so our focus in this particular topic is redox reaction, how to use certain references or criteria to solve redox reaction. We are going to be looking at references in terms of oxygen, in which case oxidation means addition of oxygen. We are going to be looking at the other one, which is reduction, will be removal of oxygen. Then the second reference is in terms of hydrogen. This oxidation will mean the removal of hydrogen, while reduction will now mean the addition of hydrogen. Then the third reference is electronegativity, where oxidation will mean addition of electronegative elements. Electronegative elements are elements that when they gain electron, they become negatively charged. Okay, so these elements are usually non-metals, apart from hydrogen. So then we have the fourth criterion, which is electropositivity. This will mean the addition of electropositive elements. Addition of electropositive elements will mean reduction. When you remove electropositive elements, then you are talking about oxidation. Then the last one, you notice I asterished it. This one is the main criterion in this particular case I just singled out, which is electron transfer. We are going to be looking at reduction of electron, which will mean oxidation, and then increase in electron or adding of electron, which will mean reduction. Okay, so oxidation in this reference means removal of electrons. Then reduction in these same terms will mean addition of electron. Now let us look at what happens between this particular potassium permanganate and the product. For potassium, which is a metal here, we are going to consider what happened to potassium here and what happened to potassium in the product side. For the reactant side, potassium here is +1 oxidation state, and in the product side it is still +1, so nothing happened here. So potassium is not oxidized, it is not reduced, it is just staying there as a reactant and also part of the product. So we are going to look at the second metal there, which is the manganese. Okay, so we have cancelled that there is nothing that is connecting this and this in terms of reduction and oxidation. So now we are going to be considering the manganese here and the manganese here, so that we know whether this is the place we are going to see oxidation or reduction. Now, whenever you see metals, the first thing that should come to your mind is reduction. Whenever you see metals, the first thing that should come to your mind is reduction. But in some cases, you might see exceptions. Okay, but just know this. Now, what do we mean by reduction? Now, for manganese here, you are going to find out the oxidation state, which if it is higher here and lower here, it means reduction, because the electropositivity has reduced. Okay, now we are going to see the oxidation state of manganese in potassium tetraoxomanganate 7. So potassium here is +1, plus, let's consider manganese as unknown, plus 4 times the oxidation state of oxygen in this compound is -2, equal to 0. We are going to be using equal to 0 because this is a neutral compound. in which case there is no charge. If by any means you see any charge here, plus or minus, it means that it will not be equal to 0. It will be equal to whatever charge here. So this neutral compound will come with 0. If it is an ionic compound, you will now have what? Minus whatever or plus whatever, considering the particular charge you find out here. So it is usually 0 because it is a neutral compound. So we have 1 plus Mn, plus times minus is minus, 4 times 2 is what? 8, equal to what? 0. So Mn equal to, when minus 8 crosses over to the other side of the equality, it becomes plus 8. Then plus 1 crosses here and becomes minus 1. So Mn, the oxidation state will now be what? Plus 7. Now let's consider what happens to manganese in the product side. So manganese will be considered as unknown, plus 2 times what? What is the oxidation state of chlorine in this particular compound? It is usually minus 1, equal to what? 0, because this is a neutral compound. So we have manganese, plus times minus is minus, 2 times 1 is 2, equal to what? 0. So manganese is equal to, when this crosses over to the other side of the equality, it becomes plus 2. So we have plus 7 here and plus 2 here. Now this is where the conundrum lies. Now if there is reduction, in which case you are seeing reduction here, it means that this particular 7 is higher on the reactant side and lower in the product side. What actually happened here is because fewer electrons are here and more of what? Electrons are here. The more you add electrons to an electropositive element, the more you reduce the oxidation state. That is the concept of reduction there. For instance, let's say this was plus 7. Plus 7. What you are going to do to get a result as plus 2 is when you must have added more electrons. When you must have added more what? Electrons. Let's say you added more 5 electrons. Minus meaning what? Electrons. Okay, because electrons are negatively what? Charged. So this will be what? Plus 7 minus what? 5. You will be having plus 2 here, which is what actually happened in this place. So reduction in this context is what? When you are what? Adding more electrons. This is why I asterisk this particular criterion. So it's just going to create a kind of distortion on the logic that you already know concerning what? Oxygen and what? Electronegativity. In which case oxygen, which is an electronegative element, as a non-metal it is, when you add oxygen or when you add any electronegative element, it should mean oxidation. But here we are saying that despite that we are looking at electronegativity as minus, that for you to have oxidation, you must remove electrons. Are you getting it? But here we are adding electrons, more of what? 5 electrons to obtain plus 2 on the product side. It means that this is a reduction reaction. If you have understood this thing, you have an edge over others. So here is where the reduction actually happened. I need you guys to understand what happened here. Okay? Because if you are having only one single metal reacting with other non-metals, you might likely guess where the reduction happened. But here we have 2 metals, potassium and manganese. So you need to know this logic, this particular criterion, before you will be able to answer this question correctly. So if this has been explained as reduction, it means that this is reduced. This is reduced. The process is reduction. The end product is what? Substance that is what? Reduced. Now, where you are coming from will be called oxidizing what? Agent. Because an oxidizing agent is an agent that what? Accepts electrons. Are you getting it? So it has accepted electrons and becomes what? Reduced. And the process is what? Reduction. What we explained here will tell you that this particular substance accepted electrons. How many electrons did it accept? 5 electrons. Are you getting it? So that manganese will change from +7 to what? -2. So we have solved the case for reduction. Could we just look at where the oxidation must have happened? Okay, let's just clean this. Now, when I started, I told you that when you look at metals, just be expecting reduction, okay? But then when you look at non-metals, always expect oxidation. But this is not true for all cases, okay? There are exceptions. So we are going to be leaving this, since we've solved it as reduction. We are going to be considering this and any other place that chlorine and hydrogen is found on the product side, so that we can compare and contrast which one will fit or suit for oxidation. So we have hydrogen and chlorine on the reactant side. Here we have chlorine here. So chlorine is -1 here and -1 here. So nothing changed. So this is not where our oxidation is going to occur. Then chlorine is here and here, so it won't work because we've used it to solve for reduction. So chlorine is here and chlorine is here. So let us solve for this and this. Okay, chlorine here is -1. Chlorine here is -1. Then chlorine on this other side is what? 0 as a neutral what? Molecule. As a neutral molecule. What actually happens here is that, apart from the fact that when we consider removal of hydrogen here, because when you see this particular compound, it contains hydrogen, then this particular molecule doesn't contain hydrogen. So you can also use that to explain oxidation, which means what? Removal of hydrogen. But then I want you to understand it using what? Electron transfer. And I told you that in oxidation, for electron transfer, oxidation will mean what? Removal of electron. So what happened between here and here, in which case chlorine was -1 here and 0 here, was that at this point chlorine -1 added another electronegative element, which is itself chlorine, to become chlorine molecule. Now, this is not just the way you do your normal mathematics by saying -1 will now give you -2. So you will be thinking that you have -2 here. No. What actually happened here is that for these ions to come and form a product which is going to give you a 0 oxidation state, it means that they shared their what? Their empty spaces, their empty orbitals. Let me just show you. Chlorine is 17, which is what? 2, 8, and 7. Okay. For protons and electrons, when it is still electrically neutral, we are going to be using the valence electron, which is 7 and 7. At this point, both the proton and the electron are still equal because they are electrically neutral. Electrical neutrality means that the number of protons must be equal to the number of electrons. Now, when we want to derive an oxidation number or state here, we will be looking at the fact that protons don't participate in chemical reaction because they are hidden inside the nucleus. So screening effect or shielding effect will not allow it to participate in ordinary chemical reaction, except for nuclear reactions. So, but something will happen about this electron. in which case 7 is bigger than what? 4. So if you are solving this and the particular valence electron that you are looking at is less than 4, it means that you will lose all those valence electrons and give it 8 and give it 0. Are you getting it? All the valence electrons that are less than 4 will be lost to be up to 0, so that particular element will become stable. Okay, all the valence electrons, example in this case we have 7, that are more than 4 will gain whatever amount of electron they will gain to be up to 8. This is to achieve stability. Okay, that is why in the periodic table you can see that group 0 is also called group 8 and vice versa. Okay, so we are going to have 8 here because this particular chlorine will have to attract additional electron, so that it will be up to 8. All right, so we have chlorine. For the fact that electron is now higher than proton, you will have to put minus. Then you ask yourself, how many numbers is electron having more than the proton? You just see that it is only 1. So the ionic state is just chloride ion, but the oxidation state is just minus 1. Okay, this is what we have here. So when this thing happens twice, you will be seeing, let's say you have 1, 2, 3, 4, 5, 6, 7. You will be seeing 1 unpaired electron on one chlorine atom. Then repeat this thing for the second one. 1, 2, 3, 4, 5, 6, 7. You see there is another unpaired electron here. So when the two of them comes up and exchange, or they pair together, it will form a chlorine molecule. Now this explains the fact that oxidation occurred between here and here, where instead of having extra ion, or let's say extra negative ion, which you are supposed to have, if you are considering it in mathematical terms, -2. Now we are having 0, because there is no free space. There is no unpaired electron and there is no free orbital. Okay, so this is why this is a neutral molecule. It means that if you have any neutral molecule, that molecule has oxidation number of 0. So we are going to be seeing this as oxidation. Oxidation, where we have -1 in the product side and 0 here, because you have noticed that you removed 1 electron. So when you remove this -1, you are having none. And I told you that in electron transfer, removal of electron will mean oxidation. So we have removed -1 to obtain no extra electrons. So this is oxidation. So the process is oxidation. The product that will be formed means that this is oxidized. And from where it came from, it means that this is the reducing agent. Apart from seeing that it contains hydrogen, which is proton donor, I mean, it's going to give out the proton, making it a reducing agent. You understand? You can use the idea of electron transfer to find out if that particular substance is a reducing agent, and the process will become either oxidation or reduction, depending on your own conclusion. So if you have understood this thing very well, I think it has made you have an edge over others. Okay, so thank you for being part of this class. If you have further questions, please refer to my DM. My phone number is 09023014038. Some of you will see my messages direct, but if you are just stumbling on this video from anywhere, you can just DM me on this particular WhatsApp number and I will give you a prompt response.